Trigonometry 6.4 to 6.6. Graphing trig functions concluded. Hallelujah. This is challenging stuff. So, done sine and cosine. Haven't done cosecant, secant, tangent, cotangent. So how do we graph secant? Well, I like to say that secant and I don't get along very well. So I'm not going to graph secant. I'm going to graph cosine, but I'm going to dot it. So, amplitude 1. Well, we're going to actually change that to none. I'll show you why in a moment. Only when it's secant. 2 pi, vertical shift, 0, horizontal shift, 0. So, just graph and cosine. Okay, now, secant's the inverse of cosine. 1 over cosine is secant. So wherever cosine is 0, 1 over 0 is an asymptote. Because it's infinity. We can't actually do it. So the 0 is where it hits the center line. Yeah, I'm going to change colors. However, if you think about it, where cosine is 1 at 0, 1 over 1 is 1. So at 1 and at pi, 1 over -1 is -1, we have the same values. So it still hits right here, the green dot, and it just runs up to the asymptote. Hits right here, runs up to the asymptote. Hits right here, runs up to the asymptote. That's it. I like to say that somebody wrapped the middle line here in dynamite or cordite or some ite and blew it up and took this curve here and just exploded it so that it ended up going elsewhere. If you really want to finish your U's, you can do that. I won't. That's just the way it graphs. If you're not sure, put your calculator in radians, go y equals 1 over cosine, hit graph, hit trig fit under the window or zoom, and you'll see there you are. So that's really it. So again, I'm just going to call this sine. Oh, I nearly forgot. Why is the amplitude none? Well, an amplitude is how far, distance, always positive, how far we go from the center line. Well, how far do we go up and down here? We go an infinite amount. So, yeah, that's it. So, sine, but again, I'll change it back later. And amplitude 3, negative, none. Period, 2 pi over 2 pi. Vertical shift, 1. Horizontal shift, pi over 2 right. So, I need some color, can't see what I'm doing. 1, 2, 3, 4 pi. And my computer's saving. Good. Pi over 2, pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 5, 4, 5 pi over 4, 6 pi over 4, 3 pi over 2. We're looking at sine. Yeah. Now, here's where I'm actually not going to dot it in, because I have to shift it. I have to shift it 2 tick marks here, 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 here. Now I'm going to dot it in. If you want to dot the first one in, that's fine. If you want to use different colors, that's fine. Finally, cosecant. Where does it equal 0? Where it crosses the center line. And then we just go up to the asymptote from there. Secant and cosecant. Same as sine and cosine, just that extra step. And it's a hassle. There's a lot going on here. I warned you it's going to constantly get more complicated. That's as complicated as sine and cosine and secant and cosecant get. Alright? Nearly forgot. Amplitude is none. Same. 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 As sine or cosine. We explained the amplitude cannot be written. Y equals tangent of 0. Tricky. I'll come back and do my amplitude, period, vertical shift, horizontal shift in a second. I'm going to show you 2 ways to do it. We talked about in a previous unit that the period is pi. This is annoying because it's one of the biggest changes from sine and cosine. We would always start with 2 pi. Well, now we always start with pi. So we got pi Alright, tangent's y over x. We're dividing by something. We're going to have asymptotes. So this is where x equals 0. So it's the same as secant. Secant, which is cosine. Cosine equals 0 at pi over 2. And at negative pi over 2. Amplitude is 1, but as you see, it's going to be none, because it's going to go up forever and ever. So when sine equals 0, this equals 0. At pi over 4, tangent is 1. At negative pi over 4, tangent is negative 1. So I don't put my dots in now because it's just going to get way too busy, especially when I shift. That's it. It runs up. A lot of people like to draw it in over here because they like to stay in the positive domain. You can chop it here if you want. You can do the whole thing. I'll probably do all of them just so I'm clear what's going on. Vertical shift in this case was 0, and the horizontal shift was 0. That's it. I'm going to do a baby cotangent over here. Still pi. Pi over 4. 3 pi over 4. Now the asymptotes, 1, negative 1, have moved because now it's x over y. And sine equals 0 at 0 and pi. At pi over 2, cotangent is 0, and at pi over 4, it's 1, and at 3 pi over 4, it's negative 1. That's cotangent. Got to memorize them or be able to derive them very quickly, which is what I actually do. I derive them while I'm working at when I'm working on a problem, but it really helps if you have it locked down. So off we go. Amplitude, none. Period, pi. There's no variable here, so it's pi over 1, which is just 1. Vertical shift, 1. Horizontal shift, pi over 2, right. This is a hassle because I can't dot a lot of things in. 1, 2, 3, 4. I'm going to guess we need 6. So vertical shift is 1, and the amplitude is 2, but not really. I'm not going to put those dots in, but I am going to dot in my center line. Pi over 2, pi over 4, 1 pi, 2 pi, 3 pi over 4, 4 pi, 5 pi over 4, 6 pi over 4. This is really busy work. You really have to be quick with your fractions. This is why trig is like the entrance into higher level math. You think you're good at stuff. If you're not really good at it, it's going to be problematic. So cotangent, just graphed it up here. It's supposed to do this. However, we're shifting pi over 2 to the right. Was an asymptote at 0, so now we move the asymptote out here. Was an asymptote at pi, so now we move the asymptote out here. 0 is in the middle, up to that one, so that's really the 3, and then the 1 is over here. Done. You can graph this. It's very, very tricky. I don't recommend it. I think it's 2 over tangent of that nonsense, and then quantity done plus 1. Very tricky. So here's your last one. Pause and go for it. Amplitude equals 3 negative, none. Period, 2 pi over 2 pi over 2. Don't even have to do that. Notice I use 2 pi. All right. Oh, geez, look at this. That's not going to change. I haven't even factored it. Negative 3 tangent 2 theta minus 3 halves. Oh, that's going to be a nightmare. Plus 2. You really shouldn't say that when you're doing these. I mean, they are what they are. They take a little longer, but it's not a nightmare. Vertical shift 2. Horizontal shift. Huh. This really should have a pi in it, so let's put a pi in there. Let's make it 3 pi. So we'll make this 3 pi over 2. Wow. 3 pi over 2 right. Now I've made a ludicrous one here. My apologies. But hey, that's life. 1, 2, 3, 4. That's pi over 2. We're going to go 3 pi over 2 to the right. Yeah, we're going to change this problem. Let's make that 1. Make it pi. So make sure I'm happy with that. Even that is stupid. No, when I pull it out, I get actually pi over 2. Yeah, okay. So, pi. What are you going to do? Don't like it. Pi over 2 right, so I need a whole nother one. 2, 3, 4. Pi over 4. Pi over 8. 1, 2, 3 pi over 8. 5 pi over 8. 6 pi over 8. 7 pi over 8. Pi. Working for a living. Still not color yet. Go up 2. Go up 3 more. Still not ready for color. Okay. Finally. Tangent should have an asymptote here. I'm going to make it solid because it's very easy for me to erase then. But we're going to shift it pi over 2. which is 4 tick marks. So we'll put it here. And that's permanent. Get rid of this one. Should start in the middle and go up. It's negative. It's going to go down. So start in the middle, but pi over 2 over. Go down to here. You know what? I'm just going to go the other way. Asymptote here, because the horizontal shift is basically the period, so it's just falling on top of itself. Just realized I forgot to put this in. Now it's wrong. Be patient with these problems. I've lost my patience. Just got to be cool. Not a big deal. This truly is a situation where I need to say, happy mathing. Good luck.